On November 3, 2011, DEA and Border Patrol agents breached a warehouse in Otay Mesa, California. Inside, they found a hole in the concrete floor, and below it, a tunnel stretching 1,800 feet into Mexico. Agents recovered over 32 tons of marijuana in a single operation. It was the single largest marijuana seizure in United States history at that time, but it wasn't an anomaly. By 2023, federal authorities had documented over 90 cross-border tunnels originating from Sinaloa Cartel infrastructure, a subterranean logistics network built over 3 decades. To understand how 90 tunnels were built beneath one of the most surveilled borders on Earth, some with rail systems, forced air ventilation, and full electrical grids, you need to understand the organization that built them and the engineering problem they were trying to solve. The Sinaloa Cartel traces its modern structure to the late 1980s, emerging from the Guadalajara cartel's collapse. By the early 1990s, Joaquin El Chapo Guzman and Ismael El Mayo Zambada had consolidated control over the Pacific Corridor, the most valuable drug trafficking route into the United States. The cartel's core problem in the early 1990s was ports of entry. U.S. Customs was expanding vehicle X-ray technology and drug detection dog units at every major checkpoint. Bribed border agents could only absorb so much product without triggering internal affairs investigations. The cartel needed a new channel entirely. The answer was geology. The Otay Mesa Plateau near San Diego and the terrain around Nogales, Arizona sit atop dense, stable soil, ideal for excavation without collapse. Cartel scouts, some of them former mining engineers from Sinaloa's silver extraction industry, identified these corridors as structurally viable for deep tunnel construction. The first known Sinaloa-linked tunnel was discovered in 1990 in Douglas, Arizona, a rudimentary hand-dug passage barely 4 feet high. It was crude, but it worked. El Chapo reportedly treated that discovery not as a failure, but as a proof of concept. The tunnel program scaled from that moment forward. Financing the program was never the obstacle. By the mid-1990s, the Sinaloa Cartel was generating an estimated $3 billion annually. A single sophisticated tunnel cost between $1 and $6 million to construct. For an organization of that scale, tunnels were capital expenditures, infrastructure investments with guaranteed returns. The cartel didn't build tunnels randomly. Every location was selected through a structured site assessment process. The ideal scenario required 2 things: a legitimate industrial building on the Mexican side to conceal excavation, and a matching warehouse or industrial facility on the U.S. side to receive product. Shell companies were the acquisition mechanism. Cartel-linked attorneys and real estate brokers in both Tijuana and San Diego established legitimate-looking businesses, logistics firms, warehouse operators, import-export companies, and purchased or leased industrial properties on both sides of the border simultaneously. Once properties were secured, construction began exclusively on the Mexican side. The surface warehouse became an active business, receiving shipments, employing local workers, maintaining a visible paper trail. Excavation happened below, concealed by legitimate operations above. The excavation crews were specialists, recruited from Mexico's mining sector in Sonora and Sinaloa states, where deep shaft mining is generational knowledge. These were not unskilled laborers. They were professional miners who understood soil composition, load-bearing ratios, and groundwater management. Construction on a sophisticated tunnel followed a 4-phase sequence. Phase 1, vertical shaft excavation dropping 30 to 60 feet below grade. Phase 2, horizontal boring, advancing toward the U.S. using hydraulic boring equipment and manual pickwork. Phase 3, structural reinforcement with concrete or wooden shoring. Phase 4, systems installation. Excavated soil was the first major operational security problem. Tons of earth removed from a below-grade dig site must go somewhere, and an unusual amount of dirt appearing near a warehouse is an immediate red flag. The solution was systematic dispersal. Soil was loaded into standard shipping containers and transported to multiple dump sites under cover of legitimate construction debris contracts. Water was the second engineering challenge. Tunnels below 40 feet frequently intersected the water table, flooding work sites within days. The cartel's solution was industrial sump pumps, the same equipment used in commercial mining, running continuously during construction, with drainage routed through the warehouse's legitimate plumbing systems. The most sophisticated tunnels, those discovered at Otay Mesa after 2006, featured 3 integrated systems. First, full electrical grids drawing power from the warehouse above via concealed conduit. Second, forced air ventilation using ducted blower systems that maintained breathable air across spans of over 1,000 feet. Third, rail systems using modified mine carts on steel track. The rail system was the key throughput innovation. A hand carry operation moving bales through a 1,000-foot tunnel requires time, physical labor, and repeated trips. A mine cart system carrying 500-pound loads, pulled by electric winch, could move the equivalent product in a fraction of the time, dramatically reducing the window of operational exposure. On the U.S. side, the receiving warehouse was the most carefully managed node. It maintained a genuine operating business, typically a freight or logistics company, with actual employees, tax filings, and commercial traffic. Only a small inner cell knew about the tunnel access point, which was typically concealed beneath a hydraulic lift, a false floor panel, or a movable industrial shelf unit. The product transfer sequence was tightly time-controlled. A shipment run was not a continuous operation. It was a scheduled event. Cartel coordinators on both sides synchronized timing windows using encrypted communications. The U.S. side team would arrive, open the access point, receive a preloaded shipment via the cart system, repack into commercial freight, and close the access before dawn. Once product cleared the tunnel, it entered a standard commercial freight network. Shipments were consolidated onto pallets, wrapped in commercial packaging, loaded onto licensed freight trucks, and moved through normal distribution channels, often to Phoenix, Los Angeles, or Chicago, indistinguishable from any other legitimate cargo. Security compartmentalization was absolute. The tunnel construction team never knew distribution contacts. The distribution network never knew tunnel locations. The warehouse operators knew only their immediate role. This cell-based structure meant that the arrest of any single node could not expose the broader network. Communications between cells relied on encrypted Nextel radio handsets in the early 2000s, migrating to BlackBerry pin-to-pin messaging by 2008, and eventually to custom encrypted phone networks, notably the Sky ECC and ANOM platforms, by the mid-2010s. Each transition was triggered by a compromise of the previous system. At peak operational capacity in the mid-2000s, the Sinaloa tunnel network could move an estimated 2 tons of cocaine and 8 to 10 tons of marijuana per month through the Otay Mesa corridor alone. Across all active tunnels, annual narcotics throughput was valued at over $2 billion per year. The geographic concentration was deliberate. Of the 90-plus documented tunnels, the vast majority clustered in 2 specific zones, the Otay Mesa Industrial Corridor east of San Diego and the Nogales, Arizona port of entry area. Both locations were selected because their industrial zoning provided legitimate cover for warehouse activity within feet of the border fence. Construction timelines were faster than most analysts expected. A basic utility tunnel could be completed in 4 to 6 months. A sophisticated super tunnel with full electrical and rail infrastructure required 12 to 18 months. The cartel typically ran 3 to 5 active construction projects simultaneously, ensuring a continuous pipeline of operational capacity. Tunnels were also treated as consumable assets. The cartel expected each tunnel to have an operational lifespan of 12 to 36 months before discovery risk became unacceptable. When a tunnel was abandoned, a new one was already under construction. The network was self-replacing, a Hydra logistics model. The workforce was substantial. Each active supertunnel required an estimated 50 to 100 personnel across both sides of the border: construction workers, security guards, warehouse operators, freight handlers, communications coordinators, and financial managers. Across the full network, cartel tunnel operations employed conservatively 500 to 800 people at any given time. The tunnel program also functioned as a product diversification platform. Originally designed for marijuana and cocaine, the infrastructure adapted after 2010 to accommodate methamphetamine, a far more valuable product by weight, and after 2015, fentanyl. A tunnel that once moved 10 tons of marijuana could move the equivalent revenue in a fraction of the mass. The first serious federal counter-tunnel effort launched in 2003 when the DEA and Homeland Security investigations established the San Diego Tunnel Task Force, a joint operation specifically targeting cross-border tunnel infrastructure. For the first 4 years, results were incremental. The cartel's compartmentalization held. The breakthrough methodology was ground-penetrating radar, GPR. By 2006, mobile GPR units mounted in standard-looking utility vans could detect subsurface voids at depths up to 60 feet while driving slowly along border roads. The technology had existed for decades in archaeology and civil engineering. Applying it to tunnel detection was the tactical pivot that changed the game. GPR alone couldn't identify specific warehouses, but combined with financial surveillance, tracking shell company property purchases near the border using FinCEN data and IRS cross-referencing, investigators could narrow a detection anomaly to specific parcels and specific owners. The administrative data trail was the second front. The 2011 Otay Mesa discovery, the 32-ton seizure, was the product of exactly this combined methodology. A GPR scan detected a significant subsurface void. Financial analysis flagged the connected warehouse as a property acquired through a Tijuana-linked LLC with no legitimate business history. Surveillance cameras and informants confirmed the tunnel was active. But the larger unraveling of the tunnel network came through informant penetration. Beginning around 2012, HSI cultivated a series of sources inside the Sinaloa distribution network in California. Not tunnel engineers, but mid-level warehouse managers who knew operational schedules. Timing intel was the critical intelligence gap GPR could not fill. El Chapo's 2014 recapture in Mazatlan added another intelligence windfall. Mexican Marines operating on DEA-provided intelligence arrested Guzman in February 2014. The mobile phones and encrypted devices seized in the raid contained construction schedules, property records, and cartel financial ledgers, a forensic map of the tunnel program's administrative backbone. After El Chapo's escape from Altiplano prison through a mile-long tunnel in July 2015, his second prison break, the tunnel program became simultaneously a source of organizational pride and a catastrophic liability. The prison escape drew unprecedented international scrutiny to the cartel's tunneling capability, prompting a U.S. congressional mandate to accelerate tunnel detection funding by $40 million. The second recapture of El Chapo in January 2016, followed by his extradition to the United States in January 2017, removed the organizational architect of the tunnel program. Without Guzman's direct oversight and the relationships he maintained with municipal officials in Tijuana and Mexicali, who facilitated construction permits and police protection, the program's operational security began to fracture. Between 2017 and 2021, the Tunnel Task Force discovered 25 additional cross-border tunnels, more per year than any previous period. The paradox: detection rates increased because operational security had degraded. Newer tunnel operators, lacking the discipline of the original network, made errors, reusing discovered property networks, inadequate soil disposal, predictable construction timing. The October 21 Otay Mesa tunnel discovery marked a new benchmark in federal response capability. Agents located and interdicted an active tunnel within 11 days of initial GPR detection, the fastest response in task force history. The tunnel was incomplete, but its rail system, ventilation, and electrical infrastructure were already installed. El Chapo's trial at Brooklyn Federal Court in 2019 produced 11 weeks of testimony that documented the tunnel program in forensic detail. Former cartel logistics managers testified about construction budgets, engineer salaries, and soil disposal contracts. The trial record constitutes the most detailed public account of the tunnel network's financial architecture ever compiled. Guzman received a life sentence plus 30 years in July 2019 and was transferred to ADX Florence, the federal supermax facility in Colorado, where he remains in permanent isolation. His tunnel architects received sentences ranging from 8 to 22 years. The engineers who built the rail systems and ventilation networks were treated by prosecutors as infrastructure criminals, not minor accessories. The structural legacy of the tunnel program extended beyond arrests. In 2022, the U.S. government invested $65 million in new sensor arrays along the Otay Mesa perimeter, seismic sensors capable of detecting vibration signatures consistent with tunneling activity. The infrastructure built to defeat one era of smuggling had permanently upgraded U.S. border detection capability. The Sinaloa Cartel's tunnel network did not collapse with El Chapo's arrest. The organization adapted, as it always had. By 2022, intelligence assessments indicated continued tunnel construction activity in both the Otay Mesa and Nogales corridors under Ismael Zambada's leadership. The infrastructure knowledge had been institutionalized. It no longer required a single architect. What the Sinaloa Tunnel program represents, in systems terms, is one of the most sophisticated sustained infrastructure projects ever operated by a non-state actor. Over 3 decades, the cartel built, operated, and replaced a parallel transportation network, underground, invisible, and self-financing, moving narcotics valued in the tens of billions beneath one of the most monitored borders in the world. The tunnels were not the product of desperation. They were the product of capital, engineering expertise, logistical discipline, and organizational patience. They were built by people who understood infrastructure as a long-term competitive advantage. And they were right. For 30 years. That's what makes this network worth understanding.